Hey everyone, thanks for coming along to this session where I'm going to be talking about blockchain development on Azure Blockchain as a Service. So, quick couple of shows of hands. So how many people came along to my session yesterday? Vast majority of you? Cool, because I'm not going to be explaining the blockchain. So if you skipped yesterday's session, you may be a little lost. If you are a little lost, don't put that in the eval, that's your fault, not mine. So another question then. So how many people here had heard of blockchain before they came to Ignite? Yeah, most of you, cool. How many people here have been doing any type of blockchain development so far? 2 hands. And out of those 2 hands, have you been doing anything on Ethereum? Half a hand. That's great. Okay, so what I wanted to do today is just show all the stuff that I've been learning as a blockchain developer over the last 7 months. Now, I've been following blockchain and reading all the academic papers and that for the last 2 years, but it's only been recently that I've been able to get more hands on it. So yesterday I mentioned how myself and Chris, we've been doing a bunch of blockchain implementations with some of our close customers. The biggest one that we can talk of is WebJet. And all of this stuff is a very, very emerging field. All this stuff is changing weekly. And so I've been hitting all the big roadblocks and spending days trying to find ways to get around this, all the problems I find. Because right now, none of this stuff is on Stack Overflow. So when you do any searches, you're the first person doing searches to try to figure out the answers to this because all of this is so new. In fact, the framework I'm going to be showing you, version 3, only just came out 8 days ago. So I had fun redoing my entire presentation because everything broke because they changed all of that. And so that's my goal of today, trying to show you all the stuff that I've just picked up to save you like 3 or 4 months of trying to figure this stuff out yourself. So if we flick over to my machine. Oh, that's our machine. Okay. Now, I was too late getting my slides in today, so instead, I've done it all with Markdown. Cool thing is, means that my entire presentation slides are now up on GitHub, so you can go grab my presentation slides right now. So cool tip if you haven't seen it yet. So Visual Studio Code has got a great inbuilt editor for Markdown. So if I press this little button over here, feedback, that's gone. You can see the Markdown being rendered there. So if I click this to split it in half, you can actually edit your Markdown and see it being updated live. So that's how I wrote my presentation slides today. Now, for you that were here yesterday, little recap. So I'm going to be talking about blockchain version 2 stuff. And the reason why I'm saying to go straight for blockchain 2 is because of this mid-tier, all this business logic which you can put into the blockchain so that people can share this business logic or executing on that same shared piece of logic. Now, I also mentioned yesterday that there's a couple out there, such as Hyperledger, Corda, and Ethereum. And again, as I said yesterday, we've been focusing on Ethereum, Chris and myself, because all of the customers we've been going to have all wanted to use Ethereum. We've heard some customers that have tried Hyperledger, but they've all jumped over to Ethereum so far. And I'm sure there are people who say they've heard people go the other way as well. But the type of customers we've been talking to have all gone this way so far. And so that's why we've been focusing on Ethereum mostly. It's also the reason why Azure Blockchain as a Service, a lot of the initial support that we've been putting out there for different blockchain technologies, most of that development so far has been based on enabling Ethereum to run in there nicely. Again, because that's what our customers are asking for. The other blockchains are getting added as well in the background. It's just our first focus has been on Ethereum. Okay, so let's go to my slides. Whoops. Okay. So some info about me. As I said yesterday, my name's David Brella, Senior Technical Evangelist at Microsoft. If you want to tweet the tweets, there's my Twitter, there's my blog. I'll be linking to a couple of tutorials that I've thrown up there. But my presentation, if you want all of these links, just jump onto my GitHub so you can grab all of these links. So you don't have to keep on taking photos of all of these links that I bring up. So let's start off with Ethereum. So Ethereum, again, is one of the different type of blockchains that are out there. They've been rapidly iterating on this. Every couple of weeks there's a new version of it that's come out with new features, new ways to interact with it. Now, Ethereum has the smart contract programming language inside of it, which is called Solidity. And Solidity is it's a Turing complete language, so you can pretty much write anything that you could write with JavaScript, that type of logic, you can write it here in Solidity. And that's what we're going to be using today. Now, you can go and write this Solidity code raw and then just use the Ethereum compiler to compile it for you. You can do that, but I'm going to be using a framework called Truffle today. And Truffle is going to help us just write these smart contracts a whole lot easier. Truffle is going to help us compile these smart contracts. They're going to help us deploy these smart contracts out to our blockchain network. Truffle also allows you to write and run unit tests over your smart contract. Because these smart contracts could be holding a whole bunch of money and value in it, you need to unit test these things more than you would normal code. Normal web code that we write as developers that we chuck up onto Azure and we can quickly iterate and be agile and just fix bugs in production. With smart contracts, you've kind of only got one chance to do this, because if your smart contract is holding money and you've got a bug in it and someone finds that bug, boom, they've taken all the money out of it and it's gone. So you have to be a little bit more structured and rigid with this. So we'll be using Truffle today. Now, the reason why I'm using Truffle, again, this is a very, very quickly developing and emerging field. Some of the other development frameworks that are out there, there's Embark and Dapple. And so, which one was first? Embark was first, but its adoption is kind of slowed a bit. Dapple is another popular one, but that one's kind of plateaued. All three of them are kind of equivalent, just like with JavaScript frameworks. A lot of them are kind of equivalent, but people have more opinions on one versus the other. Same thing here. And so Truffle is the one that's just being picked up as a de facto framework now. And so, again, that's why we've decided to adopt this. It's the new Microsoft. Rather than us trying to force stuff down your throat, we're seeing what the community is actually using, and that's what we've been adopting. So we've been using Truffle because that's got the biggest mindshare so far. It also means that I'm able to find some answers on Stack Overflow for this one. Its adoption has been going up and up. Right here, they just released version 3, which is why everyone's been re-downloading it right now. Okay, now, another quick show of hands. How many people here have actively been using NPM? Yeah, like a third. The rest of you, yeah. You're about to discover the pain that is NPM, and the pain of NPM on Windows. Now, all the stuff I'm going to be showing today will work perfectly fine in Windows, Mac, and on Linux. Everything that I'm going to be using today is going to be Visual Studio Code, which works on all three. We're going to be using NPM and NPM frameworks and utilities to do this, which work on all three. So if you do have a Mac or you've got a Raspberry Pi or anything like that, you can duplicate everything I'm doing today. Now, to get your developer environment working well with all of this stuff is... Here, I have now saved you like 1 or 2 weeks of pain of trying to debug this. I've written out a nice little step-by-step on how to do it, which is basically install Chocolatey, install NPM, install Git if you don't have it on, install Visual Studio Code, so it's just copy-paste 3 lines of code. Most of the application is now installed on your machine. So once you've got NPM on, update NPM to the latest version. Now, fun thing with NPM, so although NPM, in theory, is meant to be all JavaScripty, which means, in theory, it should run on every single platform, they then decided, wait, let's take that JavaScript and then natively compile it to the OS that you're currently on. And so a whole bunch of these NPM frameworks now when you install them, will natively compile to the one that you're on. So if you're on Linux, it will natively compile your NPM JavaScript stuff via C++ into a Linux executable. And so when we're on Windows, some of the stuff breaks because the NPM developers just assume that they're going to be on Linux. And so to do any of that stuff, that means on Linux, you need to install on Build Essentials to make sure you have GCC and all those C++ compilers, because you're now doing C++ compilation on NPM. Again, anyone who hasn't used NPM before, you're going to have fun with this. One of my workmates at Microsoft, they created this NPM package called Windows Build Tools, which is kind of equivalent to the Build Essentials on Linux. So Windows Build Tools will go and install on the Visual Studio C++ compilers, Python, and a few other things. So we've tried to make it just a single line that you run, which will hopefully set up all the compilation stuff that you need, and from that point on, NPM behaves itself. Then you install Truffle, and that's it. So it's only copy-paste 5 or 6 lines of code to get your environment up and running. And again, this was like months worth of trial and error and trying to, when I go to a new customer and we're trying to get their environment up, we'll take what I've learned so far, we'll do it, we'll hit some new snags, so I have to find a new order to try and install all of these things. Again, all of this should be getting better soon. This is also the reason why yesterday, when Chris was showing some of the things we have up on the Azure Marketplace, one of them is a VM that's already been pre-configured with Truffle. So you can spin that up and just start cranking out the codes. Next one is to do all of this development, I'm going to be using Visual Studio Code. Now, there are some plugins to do this on Visual Studio, and these new plugins will allow you to do all the stuff that I'm doing via a command line. The extension of Visual Studio Full will allow you to just do all of this within Visual Studio. Hit a thing, it'll compile them. Hit a thing, it'll deploy. But I want to show you guys how to do all of this via the command line with Visual Studio Code, so you can do this on any machine that you want to. And so in Visual Studio Code, I've got another little tutorial here which says once you've got Visual Studio installed, install these 2 plugins, the Solidity plugin and the icon theme. So then everything looks sexy. Okay, let's just start there then. What I'm going to do is open up PowerShell. Let's see, make directory demos, make directory ignite demo. Great. Now what? I'll just clear this out. That font's probably too small for you guys, huh? Font. That's probably too big. Better? Thumbs up. Great. Okay, so because I've installed Truffle, now with NPM, those who haven't used it yet, NPM, you can either, within your folder, within your project, you can install an NPM module which will just work within that folder. But you can also install NPM utilities in a global sense. And so what developers do is they create an NPM module, which is a little utility, so a command line utility, and you install that on your system globally, so you can now invoke these NPM commands from anywhere on your machine. Which means now, if I type in it just stopped working. My touchscreen works, but somehow that's fine. I just disconnect it. I'll put it back in. So I'm on like insider builds with beta software and things like that. I was thinking I really need to wipe my machine before I go on stage, but I went, no, the worst thing I can do is wipe my machine 2 days before I'm on stage. So I figured I'm either going to fight with it or I'm going to have a fresh machine. Anyway, so if things blow up, it's my fault because I've totally messed up my build on here. But it means if I type in Truffle, it will invoke NPM. Again, another fun thing you find with NPM is a cold startup time sometimes. See people nodding. There we go. So we've now got truffle installed as a command line utility that we can just run from anywhere. And so one of the things that's there is this one, truffle init. So that's what we're going to do. So we just check this folder. There's nothing in here. Truffle init. And so truffle's going to just go and scaffold out a very quick basic demo for you to start getting playing with. So it's just going to go pull down this base template from GitHub for us. There we go. And it's just telling us the type of things we can do. We can compile these smart contracts, migrate them out to a blockchain, and run our unit tests. So if I do an ls here again, we've got a basic thing. Now, pro tip. If you have Visual Studio Code installed, if you type in code full stop, it will actually open up Visual Studio Code for you, and it's pointing to that folder. So straight away you can start editing your code. Okay, so if we have a quick look at what we've got here, it's given us a few things. One, which is a folder with sample smart contracts created for us. It's created a config file for us, which is pointing to where our blockchain is going to be. It's created some unit tests for us, which we'll come back to in a minute. And then it's got migrations here, which I'll get back to. So the point of this sample code is to give you something to start with. We've got a basic smart contract here. We've got some unit tests to test the smart contract, and we've got the code to push it out to a blockchain and the config files for where that blockchain lives. So if we have a look at what the code looks like, we go with that. Again, it's very JavaScripty, the programming language here. You've got the same type of primitives that you would expect. You've got unsigned ints, strings, bytes, things like that. So a couple of those basics. You can also do arrays. So the basics as you would expect in a programming language. Now, instead of class, this is a contract. And so similar kind of concept to what you're used to in say, C#, how this will be a class. And then when we go and deploy this out to the blockchain, we're going to have an instance of this contract. So while it's still here, still a class, and when we deploy it out, we've got an object instance. So we can go and deploy this multiple times, have multiple object instances. Same kind of concept here. Now, inside of this contract, what this contract is doing is it's defining a meta coin. So if you saw my presentation yesterday, I was saying how a lot of the things that are happening on the blockchain, we do it via tokens. So you may have a whole bunch of tokens or points, and these tokens or points are tradable with other people. And that's all the smart contract's doing. We're just saying we've got our own coin that we've created. This could be for loyalty points. It could be for kudos. So it could be we're just trading kudos with each other. So what this is doing, we've got a hash table here. So this is just like a dictionary lookup, just key value lookup. But here we've got a very important primitive here. So as I said, we've got unsigned ints, strings, etc. Address is another one of those primitives. What this does is it points to an address either of someone who holds a wallet, and so I'm the person doing things on the blockchain. That address can also point to a smart contract, because every smart contract that's been deployed has an address. And so now these addresses can either be, this is the address of David's wallet, so I know it's David, or this is the address of the contract that's been deployed out. So inside of this dictionary, because it's just a key value store, we're just going to hold the address of someone. And so addresses just look like something like that. It's like 32 digits long. So that's all it holds in there. So we can put in there David's address has 1,000 coins. Chris's account has 50 coins. Just a key value lookup. That's all the smart contract's doing. So when we go and deploy the smart contract, the first thing it does is sees who's the person who deployed the smart contract, which is me, because I'm the person pushing this down. And so for me, they're just going and inside this key value, putting my address in here and just initializing it with 10,000. So when smart contracts are deployed out, all we've got in this dictionary is my address is 10,000 coins. Then we've only got three other functions. We've got get balance, and this get balance will just let me pass in an address, so I can just do a lookup. So look up my address inside of this key value, so it looks me up in that array. Dave's address has 10,000. If I look up an address that doesn't exist in there, it'll just return back null because this person doesn't even exist in our system. And then we've got one more function here, so I can send coins from me to someone else. So I'm sending it to Chris, 1,000 coins, and because it knows that I'm the person who sent this transaction, this message to go and invoke this function, this smart contract can look up some metadata about this transaction. So who was the sender? Sender was David. Okay, so we'll look up David inside of this key value, and then we just do normal arithmetic. So we just go and check, hey, does my account have enough balance? Yes, then subtract the balance, add it to the person's account in the key value store, and return true. So this is all smart contracts are. It's just normal programming languages, normal key value stores. It's just all of this is always persisted forever inside of that blockchain. And the way that we can modify these values are through these smart contracts. Now, if someone else were to try to call this, so let's say John tries to call this, he doesn't have any coins. So the first thing it's going to do is come in here. The message.sender is going to be John's address in the key value store. He doesn't have any coins, so we're just going to return false because he doesn't have any coins. And so that's the kind of basic logic you can put into these things. So let's start working with this. Now, if I want to start working with this smart contract, I'm going to have to deploy it out to a blockchain. Now, I could go and deploy it out to a real blockchain, but when you're interacting with real blockchains, you've got the problem that we have to wait for each block to be mined. In Bitcoin, that's every 10 minutes, so that means each transaction you're doing, you're waiting a minimum of 10 minutes to check all this stuff. With Ethereum, it's every 12 seconds at the moment. Very soon they'll be getting that down to about 8 seconds, and then once they move from mining to proof of stake, that'll be down in the 3 to 5 seconds for every new block. So I could deploy it out to a real blockchain, but while we're developing on our machine, we want rapid development and iteration. So we've got another utility, and this one is called TestRPC. So what TestRPC is it's a in-memory Ethereum chain where it doesn't worry about mining or creating blocks or anything like that. Just every transaction you do just happens instantly because you're just doing it for yourself in memory. We're not needing to secure this. All we care about is just interacting with something that looks like a blockchain. So it's like a mock blockchain. So I'm going to start up another PowerShell window. And here I'm going to type in TestRPC. So again, I installed this via npm, so this is now a global command that I can just invoke anywhere. We're going to run TestRPC, it's going to spin up, and the first thing it does is, if I scroll back up, just goes and generates 10 accounts for us. So these accounts are just public-private keys, so you guys now have these private keys, and you could go and send transactions, but I don't care, because again, it's just an in-memory blockchain. I'll just blow it away anyway, it doesn't matter. So now I've got a blockchain, and I've got this running now as my Ethereum client. And so I can now, this is now listening, does it say, here we go, it's now listening localhost port 8545. So I can now go and start sending messages to port 8545 to interact with this Ethereum client to start updating this blockchain. And we can do that by here. So we've got our contracts in here. If I were to go truffle, migrate, it'll go and run those migration scripts. And those migration scripts, I better show it first. These migration scripts are very similar to something like entity framework migrations. Our entity framework migrations, the very first thing it does is it creates a new table. That new table is just what's the latest version of the SQL deployment scripts that we've done. Same thing here. First thing it does is deploy out a smart contract, which holds a string of the last migration that we've done, which means at any point in the future, we may have gone up to migration script number 3. So when we run migrations, we can check on the blockchain what's the last migration script that's been run, number 3. Okay, so only execute 4 onwards. Next thing it does is actually deploy out our smart contract. So we've got our MetaCoin. So we're going go and deploy the MetaCoin out to there. Let's go and bring this back up. So truffle migrate, hit enter. It's going to go and compile my smart contract first down. So from Solidity code down into Ethereum virtual machine bytecode. And on the left, we can see it deploying out all the contracts. On the left, we can see those transactions going and happening live. So here, we can see the transaction ID, and we can see the contract was gone and created at this address. So now that we've got that address, we could go copy that address, and we could manually go and craft, like how you can craft raw HTTP calls to go and hit things on a web server. We could go and craft raw Ethereum client commands to go and invoke that smart contract. But just like you don't do them raw and you use a web browser, we're going to use some utilities to invoke that smart contract for us easier. Okay, so we've deployed out the smart contract. Now, Truffle has another cool thing, which is the Truffle console. So Truffle, one of the things that it does is does that compilation, it does that migration. It also helps generate JavaScript for you automatically, which allows you to interact with the blockchain. So we're going to be just typing in JavaScript to interact with this. And I've got this in my slides. Hey, what are you doing? Okay, one of the, so there's a generic JavaScript library called Web3, web3.js, and so everyone who does anything with Ethereum uses Web3. But Web3 is a very low-level JavaScript library, does things very, you have to do a lot of hand-holding with it. And so Truffle builds on top of Web3. But Web3, we can still do it for some basic things. Now, because here, this is doing two things. This is running the blockchain for us, but it's also an Ethereum client. And at the top, it had these 10 accounts. Let's actually copy these and put them into Notepad for a sec. So we've got these 10 accounts. So this is acting as my wallet as well, this client. So if I was to go into Truffle and say, hey, give me an array of all of the accounts, because it will go off, use JavaScript to do an RPC call over to my Ethereum client and say, hey, what are all of the accounts that we hold that we've got the private keys for that we can do things for? So we've got our 10 accounts here. Now, when I ran those migration scripts, it went and deployed them all as this account. So if I was to go and check that smart contract now and check the balance of this account will have 10,000 coins because in the constructor I said, whoever deploys this transaction, give them the 10,000, and everyone else will just have nothing, so they won't even be in that array. So let's start interacting with that smart contract. So the way to do this is, when you go and deploy out these contracts, Truffle automatically will keep track of that contract address for you. And you can go and find out where that contract is deployed by just calling .deployed, and you'll get the address of where it's currently existing on the blockchain. It will then automatically put that into a JavaScript object for you. So now it just looks like a proxy of the contract. So you now just work with your proxy class, and everything you do with this, calling any functions on it, it underneath the covers will automatically go, call that smart contract for you, get the results, and bring them back. So this is one of the reasons why we're using Truffle, because we don't want to craft all of that low-level stuff for us. So what we're going to do here is store an temp variable. Hey, cancel. Done. So this is a promise because it's an async function, so we're just waiting for it to return back to us where it's deployed, then we're just storing it into a thing, which means now we have a proxy reference to our contract. If we call MetaCoin, so now we've got a proxy, we can call any function on this smart contract. So we're going to call the getBalance function. If we go back and check out the smart contract again, just to remind you, we've got that getBalance function. We just pass in any address and it'll tell you which one. So what we've done is we've called getBalance. We are calling that web3.getAllTheAccounts array. We're saying just give us the 0th one, so this one, and it said 10,000. So if I were to do that again and do it for this account, it's going to come back and they've got 0 coins because we've looked it up. Now you can do it this way, or if I delete this, we could put it in there directly and it still works. Okay, we've got it. Let's send some coins to another account. Where are we? So let's send some coins. So just to make it easier, we're just going to store account 0 and account 1 in 2 variables. There we go. We're then going to invoke the send coin function, and I'm saying, so calling it, I'm saying, here's the person I'm sending it to, 1,000 coins, and just to help it out, we're telling it which of my accounts I'm sending it from. So I put that in, boom, it happens. Now, when it happens, because I'm invoking a command, this is being put onto the blockchain as a transaction. So I'm telling the blockchain, hey, please invoke the smart contract, invoke the send coin to send it from me to someone else. But we have to wait for it to be mined on the blockchain and distributed out to all of the nodes. So all we get handed back is a transaction, information about this transaction, saying we've submitted it to the blockchain, but we still have to wait for it to be mined and confirmed throughout the network. So in cloud computing, we think a lot of async operations. You have to think even more asyncy in this scenario because, again, Bitcoin or something like that, you could be waiting 10 minutes to 2 hours until the transaction has been confirmed. Here it's, well, best case 12 seconds, but it could be 30 seconds, a minute. And so your user interface has to reflect these type of things. When you submit a transaction, you have to notify the user that it's been submitted, please wait, and then you're going to have to tell them once this has happened and gone through. Now, because we are in-house, we can see that it's been mined, so the transaction has happened, and it's all good. So if I were to go back now and check getBalance on that first account, we've gone from 10,000 coins down to 9,000, and if I go and check the other account now, it's got 1,000. And that's the basics. I've saved you months and months and months of research right there. So all of this stuff was a lot harder. 7 months ago, this would have been impossible. This stuff is just happening so fast. Everything else you're going to do from here is going to be working off these basics. You're going to have accounts. These accounts are going to be either the people who own and control the contracts, or there's other actors which are going to be working and they're interacting with that data. And so, for example, with WebJet, how, again, I'm only talking about what's been put publicly in the news, would have WebJet and some of the other companies that they're working on. So each of them would have their account ID, and so they will go call these smart contracts. And because we know who's calling it, is it WebJet or is it one of their partners, the smart contract can go and do things based on which person is calling and interacting with these smart contracts. Okay, so we've got a smart contract working. We can now go and invoke these calls. There's one more concept I want to put into here though. So let's go and add another function. So we've got getBalance. So we know that these, we know which accounts have which amount of money. That's okay. But let's say that it's something like status points. So I fly with Qantas. And so when you fly with Qantas, you get status points. When you have enough status points, you go from bronze to silver, gold, platinum, etc. So we could put in a function here to go and, based on how many status points they have, then we can say what level that they are. So we can put that shared logic here so that anyone who's interacting with our loyalty reward program, we can know what level or tier this person is. So let's copy this. going to call this get status rank. We're going to look up, put in which account we're looking up. So we're going to just change this to an if the balance is greater than, I don't know, let's say 4,000. Whoops. It's greater than 4,000. Let's just we'll return they are silver. Else return they are bronze. Great. Now I'm going to try to call this. And it's failed. Now, the reason why it's failed is because I haven't recompiled the smart contract, which means Truffle hasn't recompiled the JavaScript helpers to help you do this. So that's one of them. But even if I do that though, I've gone and updated my smart contract code, but the smart contract that's been deployed out into the blockchain is still the old version. Now, one more thing to know about blockchains is the blockchain is immutable. Now, although these variables in state we can change, smart contracts cannot be modified. There's advantages and disadvantages to that. The advantages are you know that the business logic is how it is and no one can change it out from underneath you. So you can't have, say, a voting platform which has all the logic in there, and you can go and confirm and validate the logic and know that the voting algorithm is fair. And they can't then, out from underneath you, change the voting algorithm so it's gone and skewed in their favour, because you know that this smart contract logic cannot be modified. And when you're coming to things which are to do with, again, we're talking about money that can be held in these smart contracts. Now, we know that someone won't be able to change the smart contract and get all the money out. Downside to that is, if there's a bug in there, like in this case, or not even just a bug, we're writing a new feature, well, now we're stuck, because that smart contract is there at that contract address forever. So I can go and deploy out the new version of this. My new contract we deployed out to a new address, and the old one is still there. So everyone can still go and interact with that old version, but my new one will be at a new address. Now, you can go and destroy smart contracts. Although you can't modify them, you can get them to suicide, and when they suicide, they will kill themselves, and any money that was held inside of that smart contract would just be returned to whoever the owner of it was. So you can go and stop people from interacting with the old versions and point them to the new one. Now, there are mechanisms to get around this. This is getting to advanced blockchain development now, but to give a high-level overview of how it would work, you would deploy one smart contract at the top, which is the proxy class. We saw how there's a keyword address where we can point at addresses of other smart contracts. So what we could do is you've got the entry point, you've got the address pointer to point to which the current version of the smart contract. So you call into the top one, and it goes and calls the logic on your behalf. If you want to deploy out version 2 of your logic, you deploy out the next version. You then update your proxy contract to point to the new version until the old one's a suicide. So you can go and update it that way. Now, then you get back to the previous one that I said, well, that means someone could go and change the voting algorithm underneath you. And so one of the cool things about this is, well, that for that top contract, where you're going and you're swapping out which one is pointing to, that logic for to allow it to go to the new version, you could actually go and put voting logic in there. And so yesterday in my scenario where we had a retirement village which were doing the governance on it, there could be a function there where they all vote, should we upgrade to the new version of it? So all of them by consensus can agree if they want to go to a new version. But a whole other presentations could be done on that. Just the point of this is just be aware that updating contracts, you're going to be redeploying a whole new contract, and you're going to have to think about how to migrate people onto the new version, and proxy contracts are a way to do it. So let's go and redeploy this. So if we run truffle migrate, it'll go compile the smart contract and fail because I've got a typo. Why do I have a typo? Cheers. Bam, you're experts already. There you go. It's going to compile them, but if you remember, I said that these migrations work very similar to, say, Entity Framework. How it's gone and it's had a look, and it knows it's already run migration scripts 1 and 2, so it's gone, the network's already up to date, I don't have to run any migration scripts. Now, we could go and write a new migration script to do what I was talking about, go and deploy out the new version, get our proxy contract to go and point to the new contract, etc. But because we're in our development environment, we're just going to tell it to just redeploy it from scratch. -- reset, and it's just going to rerun those migration scripts from scratch. Now, it does mean that inside of my blockchain, I still do have the old contract there. I've still got the old migration contract in there. All we're doing is just redeploying these out to new addresses, and we're just interacting with these new addresses. Those older ones are still there. We just don't care. We're not interacting with them. So now we deploy out the new one. Bring up Truffle console again. Okay, we've got the reference to it. Let's just check how many. Yep, so this account's got 10,000. So instead of get balance, we call get status rank. They are silver. If I do it on the other account, they are bronze. Now, another concept for you. When I was going and transferring tokens between one person to the other, and I was invoking the send coin, I said how we had to wait for that transaction to be mined. Now that's because I wanted to update the state of the network. So because I wanted to update the state of the network, I called that one and I had to wait for it to be mined. But that's only when I want to update state. If all I want to do is query the current state, then we should be able to return that back really quickly. Now, one of the good things is the blockchain, all of the nodes have the complete blockchain on all of them. So any of these nodes can go and query the current state of the blockchain on our behalf, which is why if we go and call get balance, it will go and return back to us instantly. Whereas if we go and call the other one, we're going to get back a, oh, I did the wrong one. Well, anyway, you saw it before. You get back the transaction ID for you to wait. Now, you can go and it's very highly recommended, on your functions, you go and mark on these functions if they will not update state. Because that means that these nodes will know that someone goes and calls this function on the smart contract, it knows it can just go and execute it now locally just to go and return back the state, because it's not going to update any status for other nodes not need to go and process this. So you can go and put on a keyword constant here. And this one should really have it on there. I've filed it as a bug. Which means even if you try to call it without it, so if I get rid of, yeah, so at the moment I can undo that. I can call get balance and try to submit it as a transaction. But if I do a .call on it, it will go and execute it now locally. So that's an optimization to be aware of. Try to think of which functions are just there to go and expose information, internal state information about the smart contract, such as the current points, the current status. And this is also where that shared logic comes in handy. Because now we can have multiple partners which are all in the same loyalty program, and all of them locally can just go and execute, get the status of these people, and it'll go and execute instantly on each of their individual nodes. But if the customer comes into the store, buys something, and we need to give them more status points, they'll go submit the transaction because it's going updating the state for everyone. So very important concept there. Okay, so we've got that. We've got our contract. Now we want to make sure that we haven't killed anything. Question for you guys. Anyone know how to reset your PowerShell environments after all the colors have been reset? Because clear doesn't reset the colors. No one knows? Damn. Huh? CLS? Nah. This has just always bugged me. I don't know how to tell it to just clear and clear all of the... I thought reset, but damn, I was hoping you guys could teach me something today. No. Okay, let's go and have a look at these tests. Now with these tests, we can either write them whatever you're more comfortable with. So we can either write these in JavaScript, and here it's using the Mocha framework for you to do the tests and asserts. It'll go and run through these one at a time. And so one of these tests here is when the smart contract is first deployed out, then there should be 10,000 coins in the account that went and deployed it. And so you can test that. What else have they got? It should send a coin correctly. So here it's going to get 2 accounts. It's going to go and send the coin from one account to the other, and then we're going to assert that both the accounts have been updated correctly. Now, this was the only way to write tests, and as you can see, you can get very verbose. All we're doing is just sending it from one account to the other. But because of how great promises are in JavaScript, it gets very annoying. And so this is one of the things that just got released 10 days ago in Truffle version 3. Now you can actually write your unit tests with inside a Solidity contract. So here you just call a Solidity contract test, which will flag it as a test so Truffle knows that inside of it, it has test methods in it. And so here we've got a test that it's been initialized with 10,000 correctly, and it's much, much more compact. They just went and extended the Solidity programming language just for these tests, so you can go and run asserts inside of here. And so I'm going to be migrating all of my tests personally from JavaScript, from all of that down to like these 2 or 3 lines. But it's whatever you're more comfortable with. It may make sense to do something JavaScript if you're going and invoking some other JavaScript libraries, but if all you're doing is just testing this code, do this. So now that you've got these, you need to actually go and test it. Now, these aren't you can argue these aren't unit tests, integration tests, etc., because it actually has to go and execute these smart contracts somewhere. So when I run Truffle test, we're going to see for each one of those tests is going to redeploy that contract out to our blockchain environment. So it's gone, it's compiling them. We're seeing it. There you go, bam, 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 bam. So for each one of those, it was going, deploying out a contract for that test context. It would then go run through each of those tests. And so each of those tests were doing things like submitting new transactions to transfer the coins, etc., which is why we saw it do a whole bunch of transactions. It's also why I keep saying test RPC, you should be using it on your local machine, because although that executed instantly, if we were to do this on a real blockchain where we have to wait 12 to 20 seconds for each one, then it can take like 5-6 minutes for it to do that, because each one of those is going and mining the transaction before it can do the next stage of the test. So for rapid local development, test RPC. Okay, so we've got this working now. We've been doing it here locally on this test RPC account. But now we want to, just like we would in web development, we've got it working locally on our dev machine. Now we want to deploy it out to a testing environment so then people can go and test it. So let's spin up a test net. And this is what Chris was talking about yesterday, how you can go and do this on Azure. Oops. Now, the one she showed yesterday was the one that's in the Azure Marketplace. And the good thing about this is it's got some nice integration inside of the Azure portal. So inside the Azure portal, when you go, let's actually do it. If we press plus, right down the bottom, there is actually a new blockchain section. This is how important it is to our future strategy. We've got the Ethereum Consortium 1 here. And as you saw Chris show yesterday, it's just like 3 or 4 little mini panels with a couple of text fields for you to fill out. So this is good for some things, but for rapid iterations and brand new things that we're rolling out, we're doing that type of stuff on GitHub. So the template I'm going to be using is going to be this one. Now, again, the advantage of this one is it's nice and simple. You've only got 2 or 3 things you need to fill out. The disadvantages of this one is you then have to do all of that yourself. So if I go deploy to Azure, because it's just a raw template, when it comes up, we're going to see like 100 text boxes I've got to fill out. So the first time it took me about 20 minutes to fill out just all of the text boxes, but now that I know how to do it, I do it in just 2 minutes now. Yeah, here we go. So all of the things you need to handcraft JSON here and some other stuff. So all of the coolness that we've got in here will eventually be rolled back into this one, but because I'm doing cutting edge stuff, again, this stuff is being developed so quickly. This new template only came out recently. Ignore this. We're going to be using this one because it's got some nice advanced features in here, such as this dashboard that I'll be using. I've got scale sets in here, whereas the one that's in the portal at the moment, it goes and you just say how many VMs you're going to have, and that's it. It's stamped once. Whereas this one's doing a scale set, so you can quickly go and scale them up and down and change things around as you like. So I'll save you the pain of me trying to do this live because here's one I prepared earlier. But on this page, this is the link here, Network Setup Walkthrough. And here they walk through how to do it. So what the JSON looks like, so you know what to update to get it all going. Okay, so I've got this already up and running, and here's a dashboard. The cool thing about this is you can see all the stuff that's happening on this blockchain. So this blockchain is one that I've spun up now on Azure. We can see the average block time. It went up a bit because I killed one of my miners, so the average block time went up while the network was still adjusting. I brought the miner back online, so it's still just changing it. So again, Ethereum is aiming for roughly a new block mine every 12 seconds, and so it will go and adjust the difficulty up and down based on the current average block time. So if the block time is going up to like 20 seconds, it's too difficult. We'll bring the difficulty down so that blocks can be mined quicker, and that just keeps updating dynamically every couple of blocks. So we're up to block about number 40,000 so far, and we can see my miners and things sitting here. How this looks, I'll show you a little diagram. So my presentation yesterday, I didn't have enough time to show this slide. How this is working is this template, they let you set up as if you're creating a consortium of people who are inside of this. So this is company number 1, company number 2, they've got their own miners, I've got their own miners, so then they're owning some of the blockchain network. So this is what it looks like under the covers. We've got some miners behind the scenes, and then our application code is interacting with a transaction node. So this is what it looks like behind the covers. What I'm going to do is just kill test RPC. So test RPC was that test 1. When you interact with Ethereum, most likely you're going to be using the Geth client, which is just geth.exe. It's a Go implementation of the Ethereum client. So if you run this, it can go connect to the blockchain and start doing stuff. And so this is what I'm doing here. I've got the miners, which are here up in Azure, and then I'm running a transaction node locally on my machine so that I can interact with it. And so locally, let's actually start it up. Oops, that one. What's the command? So we're calling geth.exe, that should be. We're telling guest to start up. We're telling it it's connecting to this network ID, which is one that I created. But most importantly, we've got --RPC, which is going to start up that RPC port that I can go and send things to. So now Truffle, instead of talking to test RPC, is now talking to this Ethereum client. And we can see it's actually going and downloading all of the blocks from the blockchain that's up in Azure. So now my local node is talking and communicating with the nodes that are up in Azure. All the blocks are synchronizing between all of them now. So I'm now a part of this network. I can now start interacting with it. So I better do it now because it'll take a little while. Truffle migrate, because this is going to take a minute or two. So it's going to compile them out. Oh yeah, I did it in this order on purpose because it's failing because it says the account is locked. So I've got my node running locally. This node, it does have a public and private key for my account inside of here, but I don't just want anyone who's calling into it to be able to do things on my behalf. I want it locked down. So by default, my account is locked. So what I do need to do instead is when I start it, I can say unlock, and then I put in the address of my account, which I cannot remember. Get connect unlocked. There it is. So I'm locking it. It should ask me for my passphrase. There you go. So it's unlocked the account, which means now I can go and kick off the migration. Boom. So we can see that it's gone and created that transaction, and now we're just waiting for that transaction to be confirmed so it can go and start doing each one of those things. So we're deploying out that migration contract. We're then going to go and deploy out the Metacoin contract, etc. So just waiting for each one of these to be mined and confirmed. The cool thing is we go back to here, we can actually see how many transactions are pending on the network at the moment. So pending transactions, we've got 1110. So as this gets, these are being distributed and synced out to all of the nodes. They will eventually get mined. So let's set up a new one. So that's how, if I were to run Truffle test, all of that now, I would see that it would be working on that blockchain. But I've got 10, 15 minutes left, so we really want to quickly show how to get a user interface working on this before my time runs out, because that'll take a while. So let's go back, cd source, whoops, make directory, no, cd demos, make directory ignite UI demo, ignite UI demo, truffle init, webpack. So truffle init would just give you those contracts, smart contracts. Before doing truffle init, I went into the wrong folder, that's why. cd ignite UI demo. Good one, David. Truffle init, and it's not a dash, it's just webpack. So Truffle init used to give you a user interface by default in Truffle version 2, and in Truffle version 3 they went, that's probably too much for an initial sample, so we're just going to give you smart contracts. So this is why I had to redo my demo, because I had to get them to create a webpack demo, the webpack template for us, so we have a user interface. So this user interface is just going and it's downloaded the project from GitHub. It's now going installing all the dependencies for Webpack and all those other fun NPM extensions that it uses. So it'll give us a basic user interface which compiles via Webpack. So once that happens, we'll load it up. So it's very simple. All it is just it's still this Metacoin. We'll be able to load it up. A web page which just has a thing saying how many Metacoins you currently have, a little text box so you can say send this many coins to this other account. You can hit submit and go and submit that transaction. but because of this network, this may take a little while. Here's one I prepared earlier. So let's go back to this one. So we can see everything's been deployed out to our Azure network. Now I could interact with it, but that's going to be slow. So I'm going to shut everything down. We're going to go back to just using, go away. It's not going to go away. Okay, everything's been killed. What I'm going to do is I'm just going to start up test RPC again, so everything's going to go quick locally, because I'm very aware I've only got 5 minutes to show you guys this. Let's go back to source code, prototypes, truffle, webpack. And this is what it looks like. All of that basic stuff is the same, but it's added in all the stuff for a website. So he's tried to do well and put in some linting objects and things like that. But most importantly, we've got our application, which has a very just a static HTML5 page, HTML page, which just shows how many metacoins we currently have, and user interface to send coins from this address to this other address. Then the JavaScript is all the JavaScript that you've been seeing me type into the Truffle console. To get the balance, refresh balance, we're just going to find out where this contract's currently deployed. We're going to call get balance, and we can call .call, so it will go and happen instantly on this local node, and we're going to update the user interface. So Truffle migrate to go and push it out to test RPC. What's it doing? It's compiling. Oh, there we go. So it's been deployed out to test RPC. Now I can go npm run dev. npm's is going to host this HTML5 page for us, and so now our web browser will be using JavaScript to go and call to our Ethereum node to go and do things for us on our behalf. Cool. Localhost 8080. Great. Now, same thing. Because our local node is doing things for us, and that local node has accounts, and everything is executing via the account that's on my local node, when it goes and calls get balance, it's going and looking up for that first account. And so it knows who it is. Now, that works okay there. But what's probably going to happen more likely in the real world is you're going to be doing it through an Ethereum wallet. So you'll be doing an Ethereum wallet or an Ethereum browser. And so one of these Ethereum wallets is called MetaMask. So you install MetaMask. And so MetaMask now gives you Ethereum accounts here in your browser. So you can now go and interact with all of the smart contracts I was talking about yesterday, Ujo Music and all of those. You can do it via your browser now because you've got your Ethereum accounts in here. MetaMask can go and sign those transactions for you and submit it to the network on your behalf. So what I've done here with MetaMask, you can tell it to either point to the public Ethereum network or localhost, because I've got, so here I'm now pointing to test RPC because that's what's running on localhost. So if I were to go to localhost 8080, it is now, instead of talking directly to test RPC, MetaMask is now intercepting it. MetaMask is saying, okay, here's my account ID. So when it goes and calls a smart contract, it goes and looks us up and says, we've got 0 kudos. What that does mean, I can copy this address. I can go back to here and tell it to send 100 kudos to this one. Send. We go back to this one because it's on test RPC. It'll happen instantly. I've got 100 kudos. Yeah, that we'll do for now because I'm running out of time. What I will finish up with is just point you to one or two more links. So if you go Truffle Init Webpack, you'll pull down that Webpack demo, but they've got ones where they've gone into integrated things like React for you automatically. So again, I've put all these links into that GitHub repo for you. So they've got ones which is just React, React with Redux and authentication, and even better, React with Redux with Uport. Because remember how it got all preachy yesterday, saying that we should be owning our identity, and Uport was one of the ways you can do that. And so they've got an example which integrates all of this together. So you'll be working with MetaMask and Uport, and your web user interface will be working with React and Redux, and you have a good base template to get started off. Cool. And about the only other thing I can think of is I managed to get this all working in a DevOpsy way. So again, because all of this stuff is very cutting edge, a lot of people are doing what I was doing, where you're programming locally, kind of testing locally, and then you're going and pushing out to production from your local machine, which, as we all know, when we get serious with development, you don't deploy from your local machine. And so you can go and hook this up via Visual Studio Team Services. And so I've written another blog post showing how I got all of this working. So you can actually get all of your smart contract unit tests being compiled and running inside of VSTS, have it display all of the test results. So if someone goes and breaks the smart contract with the latest check-in, you can go and get all of the test results straight away. This is very raw at the moment, so I'm working with the Truffle creators to try and make this flow easier. And my next step is to get this working with release management, so we can go and do that Truffle migrate out to our local Azure testnet, and then out to the production network when we need to. So again, there is so much more I could share, but the focus of me today is just to try to get you guys over those initial humps of how do I get started with this? How do I even get this installed on my machine? If I have this installed on my machine, how do I go about getting this done? And so all of this is up on my GitHub, so jump up into there and you can got all of the links here. I may just add in those one or two commands that I did initially to help you guys out. So that truffle init and npm run dev and those things, I may just put those commands here to help you guys out. So with that, I'll finish off the formal part of this and let you guys go. If you want to ask any questions, please come up to the stage after. Cool. Thanks, guys.